What's up, brother? All right, special teams, special plays, special players. Let's get it. Got this floor plan right here, right? They're giving us some good old-fashioned numbers like 12. They're giving us a binomial with a variable in it. Got a variable over here, good old-fashioned 18. So what we got to do to answer this question, an architect creates a drawing of an apartment. So this is the apartment's floor plan, the entire rectangle you're looking at, with an area including the balcony. So if we include this area, the total is 768 square feet. They're asking us to find the area of the balcony only. The problem with finding the area of the balcony is we've got an x for this dimension and we've got an x plus 14 for that dimension. So until we figure out what x is, we've got no shot at answering this question. How do we determine what x is? We're going to have to first use length times width, multiply this information together. That's going to create a quadratic. We'll solve that quadratic, which is going to give us two solutions for x. One of those solutions would make sense with this real world example. One would not. We're going to use the one that makes sense, and let me break it down for you to show you how to do this. Okay, so length from here to here, 12 plus x plus 14. We're just going to combine our like terms, 12 and 14. So that's going to give us the binomial of x plus 12 and 14 makes 26. So you write that binomial down there. That's representing our length. We're going to have to multiply that by our width, and what that's going to give us is our area. So what's our width? Well, our width is just right here. So x times 18, or excuse me, x plus 18, just write it down as you hear it, x plus 18. That would be the width of this floor plan. Now, multiplying a binomial times another binomial, a lot of different ways to think about it. Distributive property, you can think about it as the FOIL method. Whichever way you were taught, just go ahead and multiply those out. So x times x is going to give me x squared. X times 18 is a simple 18x. 26 times x is just 26x. And 26 times 18 is 468. Okay? So that is going to be equal to our area. Now, we want to combine our like terms, 18 and 26. So 18 and 26 is going to give you 44x. Bring the x squared down, plus 468 equals area. But wait a second, we were told the area. So we can plug 768 in for where area is represented. So I'm going to put 768. I already like these two numbers. I'm seeing 68 and 68, so that's going to help me. All right, we've got to now solve this quadratic. How do we solve a quadratic? We've got to set it equal to 0. So if I'm going to set that equal to 0, I've got to get rid of 768 over here. Minus 768 cancels. Minus 768. It's going to leave me with negative 300. Bring down the terms that haven't had anything done to them. So I've got a positive 44x. And I've got an x squared. And I'm going to now have that set equal to 0, which is what we need in order to solve the quadratic. Okay, you can solve this a number of different ways. I'm just going to factor it out. So because x squared is my front term, what do we know about when we go to factor this? We know that we are going to get an x in the front term there and an x in the front term there, because x times x is what makes my x squared. It's now time for me to start thinking of two numbers that are going to multiply together and make negative 300, but will add together and make 44. Remember, when we are factoring, we're trying to split the trinomial into two binomials that when multiplied together bring me right back to where I was. So two numbers that are going to multiply together, this times this has to make negative 300. But when we get our two like terms in the middle, they're going to have to add together and make 44. Those two numbers are going to be a positive 50 times a negative 6. Okay, just to show you real quick why that works. What's 50 times negative 6? Negative 300. When I go and multiply 50 times x, I'm going to get a positive 50x. When I multiply x times negative 6, I'm going to get a negative 6x. And when I combine those two like terms, it's going to provide me with my 44x. Okay, so hopefully that makes sense. Now, if you're doing this problem, you probably have already factored quite a bit, so this is probably not any news to you. So Now what we know is this binomial times this binomial is supposed to equal 0. Well, we use the zero product property there. A times B equals 0. If that's the case, either A has to be a 0 or B has to be a 0. So we're just going to split each one of these up and we're going to set them equal to 0 so we can solve what value it could be. So I'm just going to say x plus 50 could be my 0, or x minus 6 could be my 0. Now, if I solve each of these, I'm going to get two solutions. Remember, if we were to graph the quadratic, these are the two parts where it's going to cross the x-axis at. So minus 50, x could be a negative 50. To make this true, x could also be, add 6, x could also be a positive 6 to make this true. Well, because we're dealing with a real life situation here, one of these doesn't make sense. It doesn't make sense to say that x could be negative 50 because what you're telling me there is that this distance of the balcony would be x feet, negative 50 feet. Doesn't make a whole lot of sense, does it? So you have to go with the positive value that you got in your work. In this case, it's a 6. So I'm going to take this balcony and I'm going to redraw it down here because the question is asking me to find the area of the balcony only. And the problem we had at the start of the situation was that we didn't know what x was. This was x feet. But now that we've solved for x, we can say that this is 6 feet. And we can say that this distance up here, which is x plus 14, would just be 6 plus 14 now, which we know is 20. So we've got a 20 by 6 balcony. Finding the area of that isn't all that tricky because we know we just multiply our length times our width. 6 plus 14 is, I'm just going to change that to a 20. So we got a 20 by 6. So what's the area of the balcony? 20 times 6. It's going to give you 120 square feet. And that is how you would tackle a problem like this. So one more time, what did we do? We found the total area of the floor plan by multiplying the two binomials together and getting a quadratic. We set it equal to what they told us the total square footage was of the apartment. We removed this value so that we had our quadratic equal to 0. Once it was set equal to 0, we were able to factor and solve for our 2x values. We used the value that makes the most sense, or not the most sense, the one that makes sense. This one doesn't make sense at all. So we use that value in x and x for these dimensions. And then we just multiply length times width again like we did at the start. But now we have just numbers. So it makes it a lot easier for us to just get a value for the balcony square footage. Hopefully this makes sense. Study hard, keep working. Good luck on your upcoming test.